Understanding the E in STEM means understanding in what engineering is, how engineering is used in creating the human-made world, the designed world, and that's what we'll be investigating. When we think about design, design is a manifestation of human creativity to solve a problem. It's intentional. It has a challenge. It needs to do something. The design could be functional, such as designing a bridge. It could have an aesthetic function as well, such as designing a pottery piece or a mural for a wall, or it could be experiential, having a dance routine that was created. Another defining feature of engineering design is not trial and error gadgeteering. Gadgeteering in this case means I just play around with things to see if I can create a solution that meets the challenge. Engineers do not do that. They base their design solutions on knowledge that they have, and they're looking at using math and science, as well as understanding of prior technologies to create the new design innovations. Making something is not designing it. The cat's very happy that a plank was placed across the stream, but the bridge was not designed. It was made. Whether it's even a bridge is a good question. However, the suspension bridge did have to meet certain requirements. One, it had to have a certain length, hold a certain weight, and we call these requirements specifications. It's what the design must do or possess. And constraints are aspects that limit your design solution. In this case, we might be limited to local materials, rope, wood, and so we'd be constrained by that, as well as, of course, by time, in that there's a certain time frame within which the work can be done. Interestingly, engineering can be a verb. I want to engineer something. I want to make something. It could be a noun where we're looking at exploring the human-made world. And we'll get to the habits of mind and engineering design and how they interconnect as we look for why studying the human-made world would be a very valuable part of one's education. Most of us are familiar with math, science, and social science humanities. And when we look at science inquiry, we're testing a hypothesis with repeatable and reliable testing. Rationale, so rational thinking. It has to be step by step that we're proving this. Similarly with mathematics, we're looking at rational constructs, proofs, and mathematical analysis. There is a right answer to both the science and the math. In social science and humanities, there's a different value system. It's our value system, and how we would look at things is different depending on who you are, where you came from, and your opinion shaped by your environment. And so you're going to have an opinion that reflects these value systems. It will be rationalized to make sense within that value system. Now, when we look at engineering, we're looking at something that's an optimum solution where we're making trade-offs between different elements that we cost. Maybe I'd like an aesthetic solution one way. Maybe another design is faster. And so we're looking at value systems, so we bring our value systems in there, and there is no one correct answer. There's an optimum solution based on the constraints on the problem and the value system that we have. So the artifact produced would be different artifacts, and different people would produce different artifacts to solve the same engineering design problem. Engineering has habits of mind. We tend not to think of these very often. We have to be creative. We'll look at these a little bit more. And in engineering practice, we have big ideas associated with engineering design. Here are the engineering habits of mind, and we can often think of these in terms of what we need to be an effective engineer designer. One is visual thinking. So we're looking at being able to think visually, and it helps us in our creativity where we can perhaps make a sketch, be able to talk to others about it. Engineering is very creative. We have to make things. We need connections to math and science so that we can, and this humanities, so that we can understand the technology, and we'll get to how this is manifested in engineering design. And engineers have to be optimistic. They have to believe they can make the world a better place. They have to be able to believe that the product or process that they create can be done. And of course, the technology of how things work in systems thinking is embedded in a lot of engineering of how things work together, systems, subsystems, and feedback. Engineering design, we know, is we have optimization and trade-offs. We have modeling, so we look to see if we can do predictive analysis. We're looking at societal impacts and ethics. So is what we're going to do going to work in better society or not? Or are there ethical implications that are negative that we should be aware of and mitigate or not do? Here's a way to connect the habits of mind with design. So we see how these things connect to one another. Engineers often use modeling to predict ahead of time how something will function. So you're not going to build it, take it apart, break it, and repeat this process. You're looking at how to model things, which is often why engineering has the degree of mathematics that it has with it. And we're looking at the connection to ethics and societal impacts, dealing mostly with social science and humanities. The math and science really connects as well to modeling. And the human-made world. We experience all the time, but we don't think that much about it in terms of engineering, the engineered, designed world. Oh, yes. And it can have aesthetic functions, and it could be dance. Creating a dance move structure is all part of design.